Hello there, Algebra 2A. Welcome back to today's edition of Lesson 39, where our goal for Lesson 39 is to solve two variable linear inequalities graphically. So we will talk a little bit about how to find solutions of inequalities. We'll do some graphing, and then we'll also use some graphing technology to also find the solutions to these linear inequalities. So first, a new concept, a linear inequality in two variables is a inequality that has both an x and a y variable. So an example of that could be ax plus by is less than c. When we graph out a linear inequality, we will graph out the inequality as if it were an equation. If we have a less than or greater than, we would use a dashed line. If we have a less than or equal to, greater than or equal to, we would use a solid line. So when we start getting to graphing here in just a second, we will start to see that. A solution of an inequality in two variables is all the xy pairs that satisfy your inequality. So any x and y that you can substitute in for x and y into the inequality, and if it makes the inequality true, that would be an example of a solution. And that's exactly what we're going to do in these first examples, is we are going to test these x and y values. There's your x is 0 and your y is 0. So what we're going to do is we're going to take those values, put the 0 in for x, put the 0 in for y, and we're going to check to see if the inequality is still true. So that's what I'm going to be doing. So this one will end up being pretty simple. Working with 0 is nice, and we'll talk about how 0, 0 can be used as a test point when we start graphing these. But we'd end up having 0 is greater than 7 plus 2 times 0. And all the stuff with 0 will just cancel out. So we'd have is 0 greater than 7. That would be no. So 0, 0 is not a solution. Next, we have a -1 for x and a 2 for the y. So I'm going to take the y coordinate, which is 2, put that in for y, and continue to write the inequality as I see it. 4 times the x coordinate, -1 plus 3. We'll end up getting -10 is less than or equal to -1. And we check, is -10 less than -1? That would be a yes. So that one is yes. And lastly, we'll take our x and our y and we'll substitute those in for that last equation. So we got 2 times x, which is -3, minus 3 times y, which is -1, is greater than or equal to 7. On our left side, we'll end up getting -6 minus -3, which will be -3. Is that greater than or equal to 7? And that would be a no. So that last one is not going to be a solution. So we can substitute in an xy pair and check to see. Now, because graphs are going to have infinite amounts of solutions, because they have infinite amounts of points, that means that these inequalities are going to have infinite amounts of solutions. So it's not going to be a very strategic way to find the solutions just by guessing and checking like we're kind of doing here. So we are going to talk about how graphically we can represent where all the solutions lie. And so we'll take a look at actually example 3 to start looking at how to graph these. When we graph these, we're first going to put our inequality into slope-intercept form. So we got 2x minus 3y greater than or equal to 7. So we just did this recently in our linear equations back in lesson 34, but we're going to start by, you can subtract your x's over. So you have a positive 2x, you'll either add or subtract it. So here we're using inverse of a positive 2x, so we'd subtract it over. We're left with this -3y is greater than or equal to, and then we're going to have something on this side. Now, remember that this negative, this subtract that's in front of the 3, that's going to come down to our next step. So -3y is greater than or equal to, and I just like to put the x first, so we get that mx plus b form when we get to putting this in the slope-intercept. Now I'm going to divide everything by -3. So we start by adding or subtracting the x term, then we're going to divide by the y term. we end up getting y alone. So we'll get y is greater than or equal to. Scratch that. Since I divide everything by a negative, one thing with inequalities, when you multiply or divide by a negative, that's going to flip the sign. So y is less than or equal to. A negative divided by a negative is a positive, so that would be 2/3 x. And then a 7 over -3 would be -7/3. So there's going to be our problem. And you may want to put this one into a mixed number. That would be 2 1/3. So 7/3, 3 goes into 7 twice with 1 left over. Now we'll start graphing. And since our y-intercept is fractional, it's going to cause just a little bit of issues. But there would be our y-intercept. Oops, that's only 1 1/3. 2 1/3 would be about right there. It'd be our y-intercept. All right, and then we're rising 2, 1, 2, running 3, 1, 2, 3. So there's our slope of 2/3, rise 2, run 3. We can go backwards 1, down 1, 2, back 3, and there it is. Next, we'll decide, is it a solid or dashed line? And from our notes above, since it's a less than or equal to, that's going to be a solid. And there it is. Now, a couple ways you can figure out where your solutions are. Now, I just mentioned in our previous problem that these are going to have infinite amounts of solutions. There's going to be x and y values that represent your solutions. And when you draw your line, that's called a boundary line, and it splits it into two planes, two half planes, they call it. And one of the sides is going to be your solutions. And the side that's going to be your solutions can be determined by this sign, or you can use what's called a test point. So first, if you look at your y is less than or equal to 2/3, anytime y is less than, that's going to mean we are going to shade below. So we are going to shade below. Another thing that you could do, and I apologize, the y-intercept was -2 1/3. Sorry about that. And that would mean that I would have a line looking like so. So there's your boundary line again. But still, since y is less than, we're going to shade below that boundary line. Another thing you can do is you can put in a test point. And the test point that's best to use is 0, 0. So we can go 2/3. So we can go 0 equals 2/3 times 0 minus 7/3. And that would end up saying 0 is less than or equal to -7/3, which is not true. So if it's not true, we look at where was our test point there. If our test point does not work, that means it's on the side where the solutions are not. So we would not shade the side with our test point. We'd be shading the other side. I prefer to use the first method where you just look at the symbol. Y is less than, so we would shade below the boundary line. If y was greater than, which we'll possibly see here shortly, that would mean we shade above the line. All right, heading into problem B. So we have 3x plus 6y is less than or equal to 0. We'll start by getting our x subtracted over to the other side. So we get 6y is less than or equal to -3x over 6. Next, we'll divide both sides by 6. So we would start to look at, I'm dividing by a +6, so my sign is going to stay the same. So I'd have y is less than or equal to -1/2 x. Now we're ready to start drawing our boundary line. So our y-intercept is 0. So since there is no y-intercept, or there is no b, that would mean b is 0. And then our slope is -1/2. So I'm going to go down 1 over 2. Down 1 over 2. And there's going to start to make my boundary line. Next, I would choose solid or dash, and I'm going to have a solid because it's less than or equal to. And then just like our previous problem, since it is less than, that's going to mean we are going to shade below. And so I just look at, once it's solved for y, if it's less than, we're going to shade below that line. Okay, and that would then be our half plane that represents our solutions. Next, we're going to take a look at how to graph these in your calculator. So you can stop and either open up the graphing calculator online, or you can grab your handheld graphing calculator. And I'm talking about the TI calculator. Next thing we'll do is we'll look at how to graph a linear inequality on your calculator. So we will walk through that. So first thing is, in order to put them onto your calculator, we do need to put them into slope-intercept form. So I'm going to take this top problem, 4x minus 2y is less than or equal to 10. We'll start by getting the x subtracted over the x term, which is going to be negative 2y is less than or equal to negative 4x plus 10. Secondly, we'll divide everything by negative 2. So y is greater than or equal to 2x plus 5. Oops, excuse me, that would be a minus 5 because I divided by a negative 2. So positive 10 divided by a negative 2 would give me a negative 5. At any rate, there it is. Y is greater than or equal to 2x minus 5. Next, we'll open up our graphing calculator, and we're going to hit y equals, and we're going to put in our boundary line 2x minus 5. And the next thing we're going to do is we're going to determine which part of the graph needs to be shaded. Now, since it's y is greater than, that's going to be above the line. And in order to represent that, we're going to go over and just click left arrow till we get over to where the blue, and you can select the color and the line over here. We're going to hit enter. And we're more worried about the line, so you can choose different lines. So your calculator is set up right now to graph lines. If you want to graph a shaded region, you can select that by going over one. That would be representing above the line. You can kind of see the top right part of it is shaded in, and that would represent below the line. So if we want to go above the line, we're going to select that one. If you keep scrolling, you're going to see more options. You can see more options, but we're going to use the half plane option. So we're going to shade above the line, which is this very first one here. Then hit OK, and then we can hit graph, and you can see your line. There's your 2x minus 5, and then the shading that's happening is in the upper half. So the upper above the line is what we were looking for. Secondly, we can graph that second one since it's already in slope-intercept form. So what I did there was I just went and I can shut off an equation. So right now the black or the equal sign is not highlighted in black. There it is highlighted in black. If I don't have it highlighted, it won't graph. So I'm just going to put a negative x in for that. And then it's a greater than again. So I'm going to go over to my line. I'll use this one as red, and then I'm going to go above the line again. Since it is greater than, I'm going to go above, go down to hit OK. And if you hit graph, it'll graph our second line. And eventually we'll start graphing more than one on our calculator at a time. So you could go back to y equals, maybe turn this one on too. Hit graph, and now you've got both of them, and we're going to start looking at this purple area is where the two graphs will intersect. So that'll be eventually what we start looking at here shortly. But there's how you can use your graphing calculator to graph those out. Now I understand that sometimes it might go a little fast. Remember, you can rewind the video, you can pause it at certain points to match yours up with mine. But there would be your two equations. And remember to select your half plane that you want shaded. You can just go to the left and select those over there. Lastly, we'll take a look at this story problem, and we will actually use Desmos to graph this one just to show you that there is another option for graphing calculators. We can use the program called Desmos. So it says Tran is buying hamburger patties and veggie patties for a cookout. Hamburger patties cost 75 cents each. Veggie patties cost 60 cents each. Tran cannot spend more than $30. Graph the inequality that represents the number of each patty that he can buy. Now, whenever you see a word problem, it's very important to look at the last sentence and look at what are the variables that I am dealing with. And we can see that our variables are x is going to be the number of burger patties. So I'm just going to say number of ham, just to kind of abbreviate hamburger. And then y is going to be the number of veggie burgers, which I'm going to abbreviate with VEG. Now, the hamburger patties and veggie patties each have a cost per hamburger patty per veggie patty. And to figure out the total cost of buying multiple hamburger patties, multiple burger patties or veggie patties is we would multiply the number of items we buy times the cost of each. So we're going to take, in our first case, which is the hamburger patties, we're going to take 75 cents, which is 0.75, times the number of hamburger patties plus 0.60 times the number of veggie patties. That has to be no more than 30. So no more than 30 means that it could equal 30, but it cannot be any more than 30. So there we'd have our 0.75x plus 0.60y has to be less than or equal to 30. Now I'm going to head over to Desmos and I can start to put that in. The nice thing about Desmos is you do not need to put them into slope-intercept form. So there's my representation of both patties, 0.75x plus 0.60y, or just 0.6y. And then to get into the less than or equal to, I can open up my, you'll have a little option for a keyboard down here, and we're going to go less than, has to stay less than or equal to 30. And there would represent then our solutions. So we look at our solutions, we can kind of see some amounts of the hamburger patties that we could purchase. So remember, veggie patties are on my Y, so I could buy 50 veggie patties, or I could buy 40 of the hamburger patties, and I have combinations. I could buy 20 and 10, I could buy 20 and 20, I could buy 10 and 30, I could buy 10 and 36. So you've got all these different solutions inside of here. And we'll notice also with these inequalities that even though there are some negative solutions, they're not going to make sense. So we're going to really just keep it in this first quadrant. So there's how you could use also Desmos to graph out these inequalities. But that does it for lesson 39. You are now ready for your practice. You can go ahead and get started with that, and good luck, and we'll see you next time.